All right, so interesting look at all the different roles. And like I said, right, big companies will have a role for each um, task, right, that's involved in building software systems, specifically just even designing, right, the interfaces. There's a lot of roles there, so a lot of opportunities for you to explore different careers in software. So we talked about front end, right? That's the stuff you interact with as a user. Of course, there's the back end, right? The actual backbone, you could say, right, of a software system. So the backbone is the data. So essentially, right, all software is data. You're manipulating data, you're moving it around, you're calculating it, and then you're presenting new data to the user. Whether that's Photoshop, right? Whether that's Google Sheets, whether that's Canva, right? It's all just data. So that's what we call the backend, the server side of a software system, the one that's serving up data, um, and then also working with a database, which we'll explore what that means in some of the following slides. So yeah, backend, just like with an operating system, right? If we're kind of making that analogy, it operates behind the scenes of a software. So to ensure that requests for data, right, from the front end. So the front end saying, hey, can you give me a data for the user's name? Can you give me data for the user's friends, right? If you're on Facebook. Um, so yeah, backend is making sure that the front end gets that data correctly, and it gets the data efficiently, right? It has to be quick as well. So some technologies for building backends are Python and Java. Those are very popular ones. Java is a very robust one of the most flexible. You can use it for all sorts of backends, whether it's communicating with the database, whether it's just manipulating data, right, for a server. There's also Express, right? So JavaScript option there for serving up APIs, which we'll talk about in some of the following slides. There's Django as well. So many different programming languages. So the role of a backend developer is to manage the application's core functionalities, those features. And now, of course, if we're handling data right, we also have to ensure that the data is secure as well. We don't want to be sharing, sensitive information to the wrong users. So one key component of any software system, part of the backend, is a database. So we have our back end, right? Handles, manipulates the data. We have our front end, which actually, shows the data in a nice, clean cut, easy to use manner, easy to read manner. Well, we also have something called the database, which is kind of paired with the back end. A database is a software component that solves one very specific task: storing data and accessing data. And of course, managing, right? If you want to change, you want to add more, remove, update data. Those are all different database operations, in fact. So, database is where you store your data. So, massive companies like Facebook, um, Netflix, right? Amazon, they're handling huge amounts of data, and they're relying on database components to actually provide you with the data right in that split second, right? When you click on your orders on Amazon, right, to actually give you the correct orders, it has to store that data efficiently and be able to access it also just as efficiently. So most databases today use a language called SQL or SQL, stands for Structured Query Language. Query is another word for requesting, right? So when you query a database, you're requesting data from that database. And if it's not SQL, we have a special name for it. Those are NoSQL databases. So those are the two main ones. There's an entire role just for database management, database operators, as we'll see in some of the final slides. So software systems, backend, right? If we're talking backend, one of the ways that we're able to share data across different softwares, for example, if I'm building a software for like a weather app, right? It'd be difficult for me to not just build the front end, right? Make a nice, cool looking, buttons where you can, or an input, right, where you can search your city, a button, right, where you can set the dates that you want to see the weather for. Where do I even get that data from, right? That's a whole other problem for me to solve. API is the solution for a lot of developers when it comes to getting data information from other software. So if I want to get weather data from a database or just some key features, right, that are already pre-built and made by other developers, I'm probably going to use an API. So I could use a weather API, and that's going to give me with all the information, all the weather data I need, so I can give my users the information they're looking for without actually building up that entire separate software of just storing the weather data. Somebody can already do it for me, and it can be shared right across many different applications. In fact, a lot of the different apps that you use for checking your weather are probably relying on just one, two, or three different APIs for sourcing that information. So yeah, what is an API? It's a programming interface. So just like a user interface, right, and an app allows you to interact more easily with that software, a programming interface allows you to interact with other software and grab some of the information that they're already processing. So it's a set of rules and protocols that allow different software applications to communicate and interact with each other. So yeah, it's a bridge between software. It allows me to talk to a weather API. It allows me to talk to um, maybe a traffic API. If I'm building a flights discounts app, right, where it finds the best deals on flights, I might be using a flight price API, right, to give me information on the most up to date flight prices. So yeah, APIs enable developers to access data from other applications without actually having to understand right how that other app works. And so it makes it way easier to integrate different software systems together, which also means that you can build really cool complex systems much more faster, much faster I should say, and much more easily. So an example of an API, popular protocol of APIs is RESTful APIs. Don't really need to know that, just know the definition of APIs. And then, of course, just like the cloud has made it easier for users, right, to access different web applications. Now you can go to Google Docs, right, instead of using Microsoft Word. Cloud has also offered a lot of solutions for developers, such as myself, who want to build software. It's now easier to do because we have the cloud. So, cloud computing refers to delivering computing services such as storage, processing, networking, all over the internet. So if I need to get a database, if I need to host a website, if I need server right hardware, I no longer have to buy that myself. I can just purchase those resources over the internet. So everything I need to actually have a real website, I no longer have to provide it myself. I can just go to Amazon, AWS is one of the leading cloud computing companies right now in the world. I can just go to a company like that and have it, handle all the infrastructure for me. So some of the benefits of cloud computing is that it's scalable, cost efficient, and accessible. Scalable in the sense that if I were trying to build, like for example, a server at the school, right, at LA Harbor, I would have to buy a bunch of expensive equipment. I'd have to configure it, right. I'd have to learn how to work with those computers, and then I would have to still make the program, right, that's going to run on those servers. Now, if I go to AWS, for example, and purchase some of their cloud computing services, they can actually give me the server for me, and that server is going to make my website accessible to anyone across the world. Now, let's say my server is really small, right? Because it's a small website. Then Amazon's going to automatically adjust how much resources I need. And that means it's going to be cost efficient because I'm not paying for more than I need. I'm only paying for what I'm using. Now, if my website suddenly becomes more popular and I need more resources, Amazon or any other cloud computing service, right, will automatically scale how much I need to handle, right, all those other users. And of course, it's accessible, right? Now you can share that data, that website, that database, whatever you're working with, whatever component, from anywhere, and accessible in the sense, right, that it's easier to use, right, because you don't have to be an expert on every single part of a software system. If I just know how to make front ends, then I can actually do a lot and build my own software system without being an expert in every single one of those roles. And here are some different services that cloud computing offers. You don't need to know this. Notice there's no star on this slide. But yeah, this is the class I will be teaching. And it is something I hope to do in the future. Not cloud computing, but software systems. I definitely want to create like a club here on campus where, as a professor, team up with students and build some really cool software systems for our campus community. Maybe we build some tools for teachers. Maybe we build some tools for students so they can do their work more efficiently, more quickly. Who knows? Sky's the limit. So that's definitely on the horizon. So last topic we'll be covering for this week in software systems is careers. So here are different careers. We have software developer, engineer, systems analyst. So of course, I'm a software developer or engineer. So they design, develop, and maintain software applications. A system analyst designs information systems to meet business needs. We'll actually be talking about information systems over the next couple weeks. UX UI designer, we already discussed their role in the kind of in the whole ecosystem of software systems. Database administrator, so like we saw, databases are a very important component of most robust software systems. If your app's doing anything special, right, handling enough user data, you're probably going to need a database. A database administrator is going to ensure that the data is not just accessible, right? It's quickly retrieved, but also that it's secure, and that has some kind of integrity, so that that data doesn't get to the wrong users. DevOps engineers, another important role in the software system cycle. So this kind of combines IT and software development. They essentially handle the process of updating your software. So a lot of software, right, you get updates. Maybe your iOS gets an update. On Netflix, maybe your Netflix app updates, right? In order to deliver those updates, right, those are called development operations, or DevOps. So there's people entirely dedicated in making it easier for you to just code up the new version of the software and deliver it to the user. So just delivering the software is its own separate role. Quality assurance. So sure, I can make an amazing application, amazing software, but until it's tested, right, it might be filled with bugs and unintended, right, kind of functions, right, that happen throughout the application. To ensure that the application works as intended, you need quality assurance engineers or test engineers. They essentially just, all they do is test the software. They put it through rigorous cycles of testing to make sure that once it does make it to the users, it works as it should and doesn't have a bunch of bugs. And then cloud engineer. So cloud engineer, we've already talked about cloud computing. They manage cloud computing solutions. We have product managers. Those are going to handle a team of different all those different roles, right, in a software team, in a software system team. So we need somebody, right, that's managing timelines, that's checking up on people and their deadlines, making sure that we're prioritizing the correct features, right, and working on those instead of those low priority features. That's going to be a product manager. So not super technical, but they're actually often paid more than a developer who does all the technical work. Because product manager, right, they're making sure that everything's on time, hitting the budget goals, etc. So it's a little bit of a combination of business and technology. Then we have security analysts. So that's cybersecurity, right? So they're protecting software systems. This is one of the fastest growing roles in tech today because, of course, our data is constantly under attack and we're more and more, right, connected to the internet. So the role of cybersecurity, right, is more and more relevant, more and more necessary in our society. And then there's technical support specialists, so that's IT. So all the the computer, the hardware that you use, or even the software that you use, right, to make different software systems. IT people make sure that that your tools are working correctly, right? And if you need help setting up those tools, IT is there to help you. So they'll help you troubleshoot problems and offer solutions to enhance your experience, not just as a developer, but even for users, right? There's also technical support just for regular users. Maybe, for example, Canvas, right? If you need help, they have their own support team that can help you use their application. So exercise for this week, I want you to research the different system roles that I covered in these last few slides. So 10 roles. I want you to figure out which is the highest paid, which is the lowest paid. I want you to actually list how much they make per role. Now this could be an average, this could be a range, right? A bottom to top dollar. Just find some information, right, on what the general pay scale is at for each of those roles. I want you to look up the projected growth. A good Google search for that is annual growth. So, for example, if I want to figure out how much more jobs there's going to be next year for software development, I'm going to put software developer annual growth. And then I'll put California, right? Because we're focusing on California for this class. So yeah, that's what you would search for all those 10 jobs. Look up salary and look up annual growth. And then once you get all those numbers, you're going to submit that for this exercise for this week's assignment. And then the last thing I want you to do is which role do you see yourself the most in? So I want you to write about which role you like the most and what qualities of that job align with you. It could be the pay. Maybe you love this job because it pays so much. Maybe you love a certain job, right, because it's not too technical. Maybe you love a job because it is super technical. Totally up to you, right, which job you choose. Make sure to put everything, all these three things, right, in your response. So for each role, how much they get paid, make sure to make a note of which one's the highest. And then for each role, how much is going to grow over the years. And then which role do you see yourself the most in? What qualities of that job align with you? Yep, so you'll see that assignment in week 10. And of course, let's go ahead and cover this week's lab. I'll be covering very briefly how to set up your Wix website editor. But we'll be saving it until Thursday for some extra details on putting your website together. For this week, the goal is just set up your account and maybe get started on the initial design for your website. We'll do that in the next video.